Okay, here's a really important skill that you need to develop. We're going to be dividing polynomials, and the first method that we're going to look at is long division. Now, long division can be done with a box method, so I'm going to show you both ways to do long division. This is a great skill to have, and there's another type of division that I'm going to go over as well, but this is the one you need to learn. And I really feel like if you'll take the time now to learn it, it will save you much time in the future. Okay, so division problems can be written two different ways. And so I wanted you to notice that sometimes it's just a traditional way, divided by, and it's got this. Sometimes, however, they write it this way, where they put a negative exponent. So remember that it's going to be like divided by AB with a positive exponent. So let's look at this first one. And really, all you have to do to solve this is you're going to divide the whole thing by 4CDF. Well, if you write these as separate fractions, you would have each term over the denominator. So I would have this first term over 4CDF. The next term written over the other, and I hope you're writing this, and then 4CDF over 4CDF, and then you simplify each term. So if I'm looking at this one right here, I would have 20 divided by 4, which is 5. I have c to the fourth in the top divided by c, so I have c to the third left in the numerator. I have a d left in the numerator, and the f's cancel. So in the next one, I have 16 divided by 4, which is 4. The c and the d both cancel. I have one more f on top than I do on bottom. That's 4f. And then plus, and if you'll look here, all of these cancel, form of 1. So that's actually 1, and that's that answer. Now, you can do the same thing over here with this one. I can write all of these fractions over AB and simplify. So in the first one, I'm going to have 3 and an A. The B's cancel. In the second one, I'm going to have a 6, and the A and the B both cancel. And then in the last one, I'm going to have a 5. The A cancels, and I have a B, and that's the answer. So this is pretty simple. Okay, so in the last video, we multiplied two terms together, two polynomials together. All right, so I'm going to use the box method to do that. And bink, so I've got 2x squared plus 5x minus 10. Okay, and then I'm going to multiply. So I have 2x to the third, 5x squared, negative 10x. Then I have 6x squared, 15x minus 30. So when I write this out, I'm going to have 2x to the third plus 11x squared plus 5x minus 30. Now that should look familiar because that's what this is. All right? So, in other words, if I multiply this factor times this factor, I get this answer. So what am I going to get if I divide this polynomial by x plus 3? Well, I should get 2x squared plus 5x minus 10. It works just like this. If I say 2 times 3 is 6, then what is 6 divided by 3? It's the other factor, right? It's the same thing, same principle. Okay, so let's do long division first, and then I'll show you how to use the box method to actually divide. And we're going to come back to this, so I hope you wrote it down. So I'm going to divide x plus 3 into 2x to the third plus 11x squared plus 5x minus 30. Okay? All right, so what I'm going to do is I'm going to look at x, and I'm going to say, how many times what do I need to multiply times x to get 2x to the third? Well, I need to multiply 2 times x squared. So 2x squared times x is 2x to the third. And then 2x squared times 6 is 6x squared. So I'm going to write it here and subtract both of them, even that one. So this is 5x squared, and then bring down the next term. All right? So now I'm going to say x times what? X times what gets me 5x squared. So I'm going to write plus 5x, right? So 5x times x is 5x squared, and then 5x plus 3 is 15x. Now, I want you to notice something here a second. Do you see the 2x to the third? Do you see the 6x squared? Do you see the 5x? Do you see the 15x? Do you see? All right, so this all works together. So I have, this is going to be negative 10x. Bring down the negative 30, right? So this is going to be negative 10. And when I multiply that out, I get negative 10x minus 30. Can you see I'm out of room? This is not good. Minus 30. So minus 10x minus 30. Change the sign and add it, and I have a remainder of 0. So this is the factor. Now it should look familiar, right? Because x plus 3 times 2x plus 5x, 2x squared plus 5x minus 10 gets me my original that was inside the box. Okay, so that's long division. We've done long division since the 5th grade. We just do it with variables, but it's the same basic principle. Okay, so the box method, if I were to multiply this out, I want to multiply this out again. So this is x plus 7, bink, bink, x squared plus 3. We are not dividing here. We're just multiplying, right? So we have x to the third, okay? And I know that x to the third is x times x squared, right? This next box is 3x squared, and then this is 2x. This is 7x squared. This is 21x, and this is 14. So my answer is going to be x to the third plus 10x squared plus 23x plus 14. All right, so let's see what the box method looks like when I'm doing long division. All right, so this is what I want to do. When I am doing long division, okay, I'm going to start off with the divisor, right? I'm going to divide by x plus 7, okay? And I'm going to be dividing this. So I'm dividing this by x plus 7, okay? So the first thing that goes here inside the box is the first term, x to the third. And I ask myself, x times what is x to the third? And I write x squared up here and multiply down. 7x squared. Okay? Now I know that these two boxes have to add up to the next term, right? So if I have 7x squared and I need 10x squared, this needs to be a what? 3x squared, right? So then x times what is 3x squared? That's 3x. Multiply down. So this is 21x. So I know that these two have to add up to the next term, the 23. So this is 2x. Well, x times what is 2x? That's a 2. 2 times that is 14. And then I check it against the constant value. If it's the same, there is no remainder. And I'm done. Okay? So that's the box method. We're going to practice this a lot in class, but I want you to have seen it once. Okay, let's try this one more time. Once again, this divisor is written as a negative exponent. It means that we are going to divide by 4 minus x. Okay, and so we're going to divide this. So let's look at it with long division. X squared plus 3x minus 9. And I'm going to rewrite it so that it's negative x plus 4. Okay? So I'm going to ask myself, what times negative x is positive x squared? So this is going to be negative x, and that's x squared, minus 4x, and I'm going to change the signs, 7x minus 9. So this is going to be negative 7. And so this is, is it negative? No, negative, sorry. I was right the first time. Negative 7. So this is going to be 7x minus 28. Change the sign. So I'm actually going to have a remainder here. And so I have 28 minus 9 is 19, right? 19. 19. So I have a remainder of 19. Now, what this looks like, if I do the box, is that this is negative x, this is plus 4, and so I'm going to put x squared in this first box, and this is going to be negative x, negative 4x, right? This negative 4x needs to add to 3, so I'm going to add 7x, right? And then what times this? This is negative 7. This is negative 28. And then I need this to be 9, negative 9. So I put this here, and this I'm going to add 19 to it, and this is my remainder. So the answer is negative x minus 7 with a remainder of 19. So usually what you do is you say 19 over the original divisor, and that's how you write it. Okay, so we're going to practice this. This is another skill. We're going to practice this in class. So come prepared to go over these processes, and we're going to learn it, and you're going to get really good at it. So I'll see you in class.